Did you know that scientists have discovered matter that moves through time on its own? It is a real physical phenomenon that violates what we considered one of the fundamental laws of nature, a system that changes over time, even though it should remain completely still. It is called a time crystal, and nowadays scientists can not only create it, but for the first time in history, also see it with their own eyes. What happens when time connects with the very structure of matter? And could this discovery open the door to a revolution in quantum technologies? Let's take a look. The idea of time crystals first appeared in the year 2012. Its author is Frank Wilczek, a Nobel Prize winner in physics, who at that time came up with a bold hypothesis. What if there were a form of matter that has a periodic structure not only in space but also in time? In ordinary crystals, like diamond or salt, atoms are arranged in a regular lattice. If you look at the structure, you will find that it repeats itself in space. Wilczek, however, proposed something that would also repeat in time. A time crystal is a special phase of matter in which the system repeats in time without energy coming from outside. In other words, its state changes periodically, oscillates, but without energy consumption. This contradicts the common understanding of thermodynamics, according to which any system without an energy supply should eventually come to rest. However, a time crystal moves on its own. It maintains its rhythm over time, which arises purely from its internal quantum properties. This creates a kind of ticking, but without any external energy source. Scientists call this a breaking of discrete time symmetry, which means that the physical laws remain the same, but the system itself chooses to live in a rhythm it creates on its own. It is important to realize that time crystals are not ordinary pieces of matter that we could touch. They are quantum systems in which particles or qubits interact with almost zero energy loss. In laboratories, they can be created, for example, using ion chains vibrating in a magnetic field, or in quantum computers from superconducting qubits. These systems are extremely sensitive and must be carefully isolated to prevent disruption of their delicate quantum rhythm. In these systems, the quantum states of particles regularly change between several configurations, but they never completely stop. It can be likened to a quantum version of perpetual motion. Not in the sense that it produces energy, but in that it maintains its own dynamics. The first experimental evidence of the existence of time crystals appeared in the year 2017. Teams of physicists from Harvard and the University of Maryland created small chains of ions, which they held in a magnetic field and acted upon with laser pulses. These ions began to form repeating patterns over time. Their spins flipped back and forth in a regular rhythm that maintained itself. The system behaved exactly as the theory predicted. It was stable, but never stopped. This was the first direct evidence that time crystals are not just a mathematical construct, but a real physical phenomenon. Another big step came in the year 2021, when scientists from Google used their quantum processor Sycamore to create a time crystal from qubits. Using precisely controlled interactions between them, they achieved oscillations that repeated regularly, even without external intervention. It was the first time crystal created inside a quantum computer, which confirmed that these structures can not only be observed, but also programmed and controlled. Since then, time crystals have become one of the hottest topics in modern physics. The sponsor of this channel is Buddy, your mentor and AI friend. Just enter Buddy FM and you can try it for free. In September 2025, another breakthrough occurred. Scientists from the University of Colorado announced that they succeeded in creating the first time crystal that can be seen with the naked eye. It was not about exotic quantum particles, but a system made from liquid crystals similar to those we know from LCD displays. Researchers placed the liquid crystal between two glass plates with a layer of light-reactive dye. When the system was illuminated, the molecules began to rearrange themselves into patterns that changed regularly over time. The result was a visibly color-pulsating pattern, a material that literally ticks before your eyes. This experiment is groundbreaking. For the first time in history, we can observe a time crystal as a macroscopic phenomenon. What's more, this visible crystal behaves exactly according to theoretical predictions. It oscillates steadily, responds to environmental changes, but never completely stops. This month, scientists from Aalto University in Finland connected a time crystal with a mechanical oscillator for the first time, something previously considered practically impossible. They used magnons in superfluid helium-3, cooled almost to absolute zero, and during the experiment, they demonstrated that a time crystal can interact with a classical physical system without disintegrating. The result was an optomechanical system capable of transferring information between the quantum and macroscopic worlds. Although it is currently just a proof of concept, this technology could significantly improve the stability of quantum computers in the future and enable the development of extremely precise quantum sensors. In optics and telecommunications, their ability to react periodically could pave the way for new methods of light modulation and more efficient information transfer, where the time crystal would function as a perfectly synchronized rhythm that never loses its beat. However, other ideas are also emerging, such as using visible time crystals as protection against counterfeiting. Because they create unique patterns that change over time, it would be practically impossible to copy them. Such dynamic watermarks could protect banknotes, passports, or valuable documents. Time crystals prove that matter can also have a temporal structure. This fact could change not only our technologies, but also the way we understand the universe itself. What do you think? Could time crystals bring quantum technologies from laboratories to the real world? Write your opinion in the comments and don't forget to click like and subscribe so you don't miss any news about future technologies.